This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Good morning, afternoon, evening, dear listener, wherever you are.
Good morning, Peter. Welcome to a new episode of our Industrial AI podcast. What do you have in the news part?
What do I have? I still getting messages from CES. You as well?
Las Vegas, yeah.
Right. Well, the next one is coming up. Let's talk about that later. But as far as I have seen Roland Busch, the CEO of Siemens. Yes, he's our partner, but nevertheless, or even because, I think he was the star, right? Introducing the industrial AI operating system together with Jensen, many others.
Exactly. I think he had the keynote, right?
Yeah, that's what he did. I didn't look at it completely. I looked at pieces here and there. And actually, I think it wouldn't be a bad idea if we could ask Roland, if he could join us 10 minutes. Why don't we ask him here directly? Roland, if you hear this,
Sure.
Would you find 10 minutes in your busy schedule to explain the industrial AI operating system to our listeners? That would be great. Thank you very much.
But that's a new term, right? Operating system, industrial AI operating system. What is that?
Yeah, exactly. And to be honest, I didn't get into the details. And,
Yeah.
and maybe we are going to be lucky. And just in case Roland does not listen to our podcast, maybe someone close to him does and can bring our request forward to him.
It's interesting because I think 1 year ago, the big topic was industrial AI foundation model by Siemens, right?
Yeah.
And this year is now operating system. So is it a new topic? Does it work together? Is it a new strategy?
Yeah, I think it's developing, yeah.
Yeah, exactly. Or still searching for something.
Well, yeah, but my feeling is they have a very good feeling what it is that they want to do. But then again, I haven't heard the details, so it would be great if if Roland could explain it to us himself. Have you been there at all to CES? You've been traveling a lot last year, everywhere.
No. I thought CES is more focused on consumer electric, right?
It was,
yeah. And now with Roland Busch, with the keynote, it's now an industrial community. I'm not sure.
Yeah, just everybody wants to be there. I think I was there long time ago at the time that I was kind of in the let's call it the consumer space. I mean the Intel Inside. I mean appealing to consumers. And at that time I went there, and I do believe that Intel hadn't been there yet. And I was looking at shall we be there? I was there a couple of times at that time. I was there later. I was there with Stefan Hoppe, Uwe Steinkraus, Tom Burke at that time.
With OPC Foundation, you were
OPC Foundation, exactly. But that was not for CES. I think that was in Las Vegas, just a different show. So it was Las Vegas, but it was a very special one, actually. Not going to get into the details. What happens in Vegas stays in Vegas, right?
Exactly.
I'm going to come back to that maybe in a minute, yeah. But yeah, let's see. I thought of that as well, yeah. I'm preparing a podcast with Norbert Jung from Bosch. They were there, and that's also from manufacturing, industrial AI manufacturing capabilities. So let's see. Yeah, you're right. I mean, at that time I was moving, and it was a huge consumer show, and now maybe the industry is appealing. Like at that time, Intel was appealing to end users, right? Is that happening to the overall industry? Question mark. Not sure.
I don't know. Because you mentioned Siemens, right? And there was an article about Jan LeCun's new startup in Paris. And I comment on the article because he wants to build large industrial AI foundation models, right? All about images, time series, etc. And I commented that won't be easy because small and medium-sized business are aware of their data. And then there was a guy and he wrote an answer and said, federated learning. And I said, federated learning. We haven't heard anything about that in a long time, right? So maybe now it's a time, it's a revival of federated learning. Let's see. I wrote him a message. I'm quite skeptical. Let's wait and see. What do you think?
Again, in the preparation, which I did yesterday, and just for you listeners, if we talk about 1, 2, 3 other things, from the moment you're going to be able to hear this Thursday, we're recording now on Monday, I was preparing yesterday, and I can only share again in my preparation with the podcast for Bosch with Norbert, it's very clear that they have a very deep founded understanding of the value of their data. And that's only, but that's just one example. But but they know.
But federated learning, Peter, federated learning.
I'm not sure. But I strongly agree. I haven't seen the term for a long time. To be honest, I thought at the moment it was a great idea. It was about, like, instead of, what was it?
Collecting data, sharing models, right?
Yeah, but it was this wonderful quote, not the data doesn't come to you, the algorithm comes to you, right? So you keep your data where it is in the algorithm. So I'm not sure if that's still working here or there. I mean, to be honest, since 10 years, typically, if I don't ask it specifically, the issue, the opportunity always comes up. The question of cloud or local, right? We've been doing that all the time, but we haven't been discussing this in between kind of solution of federated. So I don't even understand how the person came up with that thought. Not sure.
Yeah. But maybe we should keep an eye on that topic. Maybe really it's coming back. It's a revival of federated learning when it comes to build great, big foundation models. Let's see.
Yeah, let's see. But then again, I think the very clear development in our world, in our industrial world, is towards inference, close to where things are happening. That's what we talked about 5 years ago. And actually, I keep on asking wherever and whenever I talk to people on the podcast, outside of the podcast, I'm still really not completely understanding. Oh, I don't know. I was thinking, who did I talk to last time? Actually, it was Gemini. I was asking Gemini what she thought of it, and I call her a she, the algorithm.
Why is it a she?
Yeah, and that's as I say, she, because it's a female voice. So I can.
Okay. But you can change that. Do you know that?
Oh, the female voice is perfectly okay in this case to me. Yeah, and completely still not understanding why we need trillions of new data center investments. Yes, I do understand that there's, whatever, 5, 6, 7 big tech companies, and each of them want to be the first and the best in training models and coming 1, 2, 3% better at what is there. And I must say, with what Gemini delivers is like really, really very, very amazing for what I do. But that's on the side. But I still don't get it, because at least in our world, I mean, everything is going to be on the edge, very close to where things are happening. There's no need to do any inference in the cloud, right? So I'm not saying that I do not understand that we do want to continue, but with the numbers that we see that are supposed to be developed in cloud infrastructure, for me, I can't follow.
Yeah, I think I mentioned it 4 or 5 episodes. I talked to a manufacturer, and he said we cannot sell cloud products to our customers because there's no ROI on that. And yeah, it's a topic for them.
Yeah, that's the other thing I'm not sure I've understood. Or always the difficulty of selling software, basically, right? Selling the AI service, I guess. So they're selling it as a solution. So here is, well, whatever. I mean, in the past, it was, here's my piece of hardware, and there is certain software, operating system, for example. The operating system was never, or was it sold? Maybe. I don't know. Yeah, I guess so. I mean, has Windows been sold? Windows 1, 2, 3, 4, 5, 6, 11, wherever we are? I guess so, right? It has was
Yeah, sure. Do you remember the license keys? Everybody was sharing this license key.
yeah.
Yeah,
No, yeah. I just don't recall. Yeah, right. There you go. Yeah, let's see.
yeah, exactly.
What do you have?
Do you remember the guys from Pass Robotics? I did an interview last year with them about the again foundation model when it comes to welding, the welding model. They are from Ohio, so in the heartland of the US, flyover state. And they have published figures today, or now not today, last week, and they have over 100 million annual contract value achieved. I was very impressed. 100 over 100 million annual contract value, and you see the topic physical is AI is slowly taking off, I would say. So it's a huge topic in the industry in the US when it comes to welding, especially welding is a crucial domain. And I think we will see the same here in Europe when it comes to welding or when it comes to other domains with robots. Let's see. But over 100 million for a startup. Congratulations to the guys from Pass Robotics.
That's what we are going to, or the time that you hear this, dear listener, we will have talked about a lot during our 1.5 day Amsterdam AI conference, right?
Exactly. We talked with Stratis about physical AI, scaling, simulation versus reality, but we will do a special episode on AI in Amsterdam, I think, in the coming weeks. So we can summarize there the whole topics, right?
Yeah, right, exactly. Okay, Ohio. Oh, interesting. We have two very, very very good players in our marching band. That is the actually term for what our Bavarian band is. I looked at it, and they are from Ohio, actually. Talking of Stefan before, as I said, CES.
Stefan Hoppe.
Exactly, Opus UA. There is a post by Ken Wenzel. He works at Fraunhofer Machine Tools, and he says data without context is just noise. In a modern factory, you don't need sensor _742, whatever kind of readings. You need to know which machine it is attached to, which production line is that machine on, who's a technician on shift right now. And he says this is where linked in factory, interesting term, on a linked factory, changes the game. And then I answer and I say, isn't that what Opus UA was supposed to take care of?
Yeah, exactly.
And by the way, I'm not confusing now the Opus UA Foundation podcast with our Industry AI podcast, because at some point in time, and exactly here, of course, they do come together, right? To which then Ken replies, great question. It's a common point of confusion, but we actually see Opus UA and what he calls linked in factory as a perfect pair rather than...
No, not LinkedIn. It's a linked factory.
Did I say again LinkedIn factory?
Yeah,
Sorry.
it's not a LinkedIn factory.
Linked factory.
For your postings, you can have a LinkedIn factory, but this is a linked factory.
Looks exactly. Yeah, but okay, it has to do some linked factory. And then he says Opus UA is mainly used as a tree. Exactly. It's actually an object-oriented data model, because that's the information model, right, that I talked about many times. Excellent for hierarchical access to specific machines variables in real time. But as soon as you need to query across silos, e.g., find all the bearings from vendor X across 5 different factories, the tree structure becomes a bottleneck. And he says then the resource description framework is a web, the linked factory takes those Opus UA nodes and turns them into a global knowledge graph. And that's what I've talked.
So you are the OPC Foundation expert, right, Peter? You are running the podcast on OPC.
Well, a little bit.
Do they have a strategy now on agents?
Well, I don't know. I don't know. I'm not that close with it. I would say exactly, and I have linked exactly, to what he does here. He says and I've said in the past, the information model of Opus UA is exactly like this global knowledge graph, right? And he says this allows for horizontal queries that OPC UA wasn't designed for, etc., etc. And my point is over now to Stefan Hopper, OPC Foundation president. And yes, I think I have suggested, and maybe I've actually asked exactly that question. I'm very interested in asking it again. And the interest, of course, is, what is the role that OPC UA will be playing? It's the same thing with MCP that may be sitting on top. And now there's another one, the resource description framework, or call it, what is it? Linked factory. So very much looking forward to a second direct request. Stefan, very much looking forward as a topic for both, I think, the OPC Foundation podcast, as well as for us here, because for us here at the Industrial AI podcast, it's very interesting. Anywhere we are all the time, we are being suggested that it's important to get your data organized in one or the other way, and one or the other way may be, and very importantly, through an OPC UA information model. And at the same time, we see developments where we then have questions, and we want to understand what the continued role of OPC UA in an agentic world is going to be.
Okay, perfect. What else do you have, Peter?
I have two more maybe. Oh yeah, very quick one. It's still from CEF. When Roland was the human star at CES, I think there was a second. That was the industrial humanoid star. You know which one that was?
Atlas.
Yeah, very good. Atlas by
Boston Dynamics and Hyundai, I think. Hyundai is a part of Boston Dynamics. Yeah.
They bought him, right? Yeah. They've been moved from one to the other to many different companies in the last 10 years. But we all recall Boston Dynamics. They were the ones where already 3 or 4 years ago, they were jumping in the factory halls, right?
And Figure with BMW, I think.
Yeah. Oh, right. But at that time, that's what they were. Now, this time, and I did look at it, maybe just like 2-3 minutes. This one looks almost like
a machine.
Well, it looks like almost natural because, as as our listeners probably know, I've never been a real big fan of humanoids in the factories, and I haven't been sure until I now saw. Well, there is really like a machine. There is a machine, and the machine, yes, looks like
it's a machine. Yep.
Maybe like with arms and legs, and it's not so clunky anymore. It almost you can really imagine that this machine is capable of taking in its hands whatever up to 30-40 kilos, I believe, or something like that. So can really be doing useful things. I think that's what it was showing, and I thought it was somehow impressive. And I must say, this time I didn't care that it was like whatever you call it. For me, it was a robot almost, and I didn't care that it looked like as a humanoid. And that was the first time. Maybe the humanoids, as in those for consumers, with their eyes looking at you and can I help you, dear poor human. This one was not doing that, right? I mean, this one is supposed to be now for the shop floor, I believe, right? For doing hard, tedious work that maybe is better for a machine than for humans.
Exactly. Let's see what's going on. I will visit the European Robotics Forum in Stavanger in March or is it in February? I'm not sure. Let's see, because there's a Norwegian humanoid robotics startup. There are 2 German Agile Robots and Neura Robotics.
Oh.
So let's see what are their answers when it comes to Atlas. Yeah.
Oh, you're traveling up north again.
Exactly, up north to Stavanger. Yeah.
Many people traveling north in Europe these days, but it's another topic. Although I do want to finish, if I may. I do want to finish with that.
But they're all coming back.
The topic is actually very close. You wouldn't understand, but if you, as the world is traveling to Davos, and Davos is not in the north, Davos is in Switzerland. I think starting today with the World Economic Forum. Of course, lots of AI in industry, interest activities, but I will not travel there. But I just started rereading, I should say listening this time, to the famous book by the late German author Thomas Mann.
Oh, the Zauberberg.
Of which Yeah. In English, it's called the Magic Mountain. I'm listening it in German, right? Now that is set in a Swiss sanatorium, right, just above Davos.
Exactly.
The main character visits his cousin. He plans to stay 3 weeks, but stays for 7 years. And if that's that's the story, very good, very interesting story. But in the background, this is all about it plays like more than 100 years ago, right? And it was just in the years before a breakout of World War I at that time.
Exactly. We are the industrial AI podcast. We are also the education podcast.
Yeah. I just happened to read, because in the story you sometimes hear about that they're coming down the mountain, and you go to Davos village. And as I hear that, and then at the same time coming out of listening the book, I was here, and this morning I actually heard that everybody's traveling to Davos. Let's hear. Maybe in 2 weeks we will tell you.
Exactly. And I'm currently reading a book about Thomas Mann, Escape to France. I will share that also in the show notes. Very interesting about his escape. First he was in Lugano, then he went to France. So it's very interesting. Yeah.
Very good. As you said, here you go. Yeah. Industrial AI podcast. You can learn all about literature, what's happening in the past in Europe.
Education podcast, literature, education, whatever you want. Exactly.
Robert, we'll see each other tomorrow.
I have one more. We will see each other tomorrow in Amsterdam, but I have one more reading tip from the Financial Times, and there's a connection to your humanoid. And the message is, or the question is, why we are not seeing the ChatGPT moment in robotics now. So this is very interesting. I will share this link also in the show notes. And in the main section now, we are in Amsterdam, and I have an episode from the Netherlands. I met Wouter from VBTI, and he's waiting with his cucumber robot. You remember, right?
Oh, really?
Yeah. And now the cucumber robot serves industrial applications. And that was exactly what you said. And back then, we will see how to transfer development from one domain to another domain. And this is an interesting approach, because the cucumber robot is doing now different stuff when it comes to industrial application.
Oh, I'm very much looking forward to, because the thought was, and me being from the Netherlands, very much looking forward to travel there tomorrow. I don't come there that often. And having been kind of raised in an environment of agriculture and all these plants that grow, and that's what he was explaining the last time, 1 or 2 years ago, right? And these plants, and then the robot needs to decide if, what am I going to take? Let's stick with the cucumber, and needs to be careful. And then these leaves need to be taken off, but there is a very important leaf, and
exactly.
So there's understanding as well. And that was the thought at that time. I'm not sure it was my thought. I thought it was his thought. Maybe
it was your thought. You mentioned that in the podcast.
Oh, really? Okay, yeah, because it's so complex, and if they can solve these complex things, then now they can move it to you. Okay, I'm very much looking forward to him.
I don't know the English name, but it's all about biegeschlaffe Teile.
Oh, no, I don't know the English name either.
What is biegeschlaffe Teile? I don't know.
I've no idea. I don't know it in German. Robert, see you tomorrow.
Okay. Yeah. Perfect, Peter.
Thanks. Bye-bye.
See you tomorrow. Bye-bye. My name is Robert Weber, and my guest today is Wouter from VBTI. Hello, Wouter. Welcome.
Hello, Robert. Thanks for having me.
Glad to have you with us.
Yeah, it's nice to be here as well. I've never been on a podcast before, so this is quite exciting for me.
Oh, great. But some of our listeners are already familiar with the company. I would like to remind you guys of the episode with the cucumbers and the robots. But today we want to talk about Adam 1. I'm really looking forward to what is Adam 1 now. But before we do that, Wouter, please introduce yourself briefly to the listeners.
Yeah, my name is Wouter van Breemen, and I've been working at VBTI now for 4 years. My background is in engineering. I did mechanical and also software engineering. But now I'm working also on product development, and specifically our inspection robot for high-tech called Adam 1.
I'm really looking forward. So what is Adam 1? I read your LinkedIn post, and it says Adam 1 doesn't just automate inspection, it understands inspection. What does that mean?
Yeah, it's something really new. So what we see a lot is that Basically, anyone can make a inspection robot, right? But our robot is very different because it's very smart. So compared to other robots, you don't have to program Adam 1. You can just place any part, press start, and it will just inspect whatever you put on its table. And that's something very new.
Mm-hmm. What did you learn from the cucumbers, or is there no knowledge transfer from the other projects?
Yeah, there's actually a lot of knowledge transfer here. So in the Cucumber project, we had to deal with a very complex environment where we had to track which part of the cucumber plants are leaf stems and which part is the main stem so that we can cut them. And this was very challenging because normal 3D estimation technologies like stereo vision wouldn't work in this complex environment. So in the greenhouse project, we designed our own 3D algorithm, which is based on stereo vision, but on the background, it replaces the algorithm with AI to do the 3D depth estimation. And this is something we are using now in our inspection robot to really scan what is on the table. And that's why Adam is so smart.
Okay. Why Adam? Is this an acronym for something, or is it only we need a name for our robot?
Yeah, actually we have two reasons for it. So first reason, Adam is one of the optimizers used in deep learning. It's one of the first optimizers used. So this is very cool to reference to that optimizer. And the next thing was, we wanted to make a robot that's so smart that you cannot give it a number or a name, but we had to give it a real name, a person's name.
Okay, great. Can you please share a little bit what you did when it comes to AI, about the model and how robust it is? How do you deploy it? What is the model capable of? So what kind of cameras do you use? So can you please share a bit about that?
Yeah, and maybe a question back then, which model? Because we have quite a lot of models in Adam.
How many models do you have?
I think right now we're using 5.
Isn't that too complicated to run 5 models on a robot? How do you handle that?
It's okay. So we have one quite a beefy computer on the robot, and there's a powerful graphics card in there.
Okay, GPU and a robot.
Yeah, and this graphics card can run all those models with ease, I would say. And that's because vision models are not as big as those language models everyone is using nowadays. So you can put quite some models on there.
Okay, let's talk about the 5 models. Start with the first model. What is the first model doing?
Yeah, so first of all, if we press start, the first model that will do its job is the depth estimation model. So we start by taking some pictures, and our depth estimation model will use those pictures to make a 3D point cloud of the object that is on the table.
That is not rocket science, right? So this is a common way.
Yes, exactly. But afterwards, we have all our inspection tasks running. So there's various functions that NM1 can complete. And one of them is scratch detection, for example. And for scratch detection, we use those pictures and we process them with our models to find all the scratches in the image.
Okay, that's also not a rocket science, also a common approach, right?
Yes.
Let's dig a little bit deeper when it comes to very, let's say, unique approach.
Yeah, I think one of the more interesting technologies that we are using is for the development of our missing parts algorithm. So missing parts is quite a complex problem. It's basically you have some assembly and maybe there's a bolt missing somewhere. And we want to be able to detect that with just one sample. And we've seen that you can train AI models if you have 1,000 annotated images. There's no issue there. But it's a bit more complicated if you go to one-shot learning, where you have like one golden sample, and then afterwards, you have to already judge, is this okay or not okay?
How do you do that?
Yeah. So right now we are using approach. We're using Siamese twin networks.
Mm-hmm. What is that? I've never heard that.
Yeah, it's actually a little bit of an older method. And in this network, you train a model to basically tell if something is the same or different. Yeah, and we train this model across all kinds of images in the inspection and manufacturing domain. And afterwards, we can give it 2 images and ask the model, is this the same or is it different?
Okay, that's interesting. And what else is unique in your approach? And how do you combine all these models? And how efficient is that running a GPU next to a robot? But can you share a bit about that?
Yeah, which question first?
How efficient is it to run a robot with a GPU?
Yeah, that actually works quite well. So in general, we see that our robot is a lot slower than the GPU. So we have no issues processing the images in time.
But is it a standard robot or is it a specialized robot arm or what is it?
Right now, we're just using a cobot.
Okay. But from an ROI perspective, you have a GPU and you have to sell the GPU and the robot. Isn't that a problem at the end?
No, actually no, because most of the cost for us to develop one system goes into the software development. So the GPU and the robot together, they have a price, but most of it goes into the R&D to develop all the models and all the smart systems that we make.
Yeah, but when you want to sell the robot, right? So I think it's a challenge to sell a robot and a GPU, right?
It's actually okay. So usually we sell the whole thing as a solution to a client. So. And that works actually quite well.
Okay. Can you share a bit more about the USP? So you already mentioned the first USP with the model. Do you have more AI USPs on the robot?
Yeah, so our main unique selling point compared to the other robots is that you don't have to program it and that with one press of the button, you can get your part inspected. So we've not seen any robot on the market, and we've also not seen any partner who has such a robot. So we think this is a really unique selling point of our application.
Yeah, but how do you do that? Because that's a very challenging problem, right? And you mentioned nobody solved it yet, but how do you solve it?
Yeah, so we solve it just by the combination of techniques we have tinkered on in the past few years, right? So one is the depth algorithm, but other are some algorithms to determine where to take a picture most efficiently. And combining all this knowledge into one product, made it work. Maybe it also has to do with that we are based in Eindhoven. And in Eindhoven, you have a lot of the semicon companies, and they are all dealing with these high mix, low volume parts that they produce. And this is maybe something also a little bit unique to the region, because you also see a lot of manufacturing sites where parts are produced in large quantities. And for that, our solution is totally not interesting.
So you're focused on high-tech industry, or am I wrong?
Yeah, right now we're focusing on the high-tech industry, but we do see that the robot can be applied in many industries. But high mix, low volume is the main case where it's very interesting to use this technology, because that's the moment. If you only need to inspect maybe 10 parts, you're not going to automate it and make a complicated program for it that takes maybe weeks to develop. You're just going to inspect it by hand. And we have a solution that you don't need to program, which makes it now, for the first time, I think, feasible to inspect high-mix, low-volume parts.
Mm-hmm. You are also connected to the ASML guys there. Is there a connection or a partnership with ASML on this topic?
Not yet.
So I want to come back to your 5 models. I think we stopped with the 3rd model. Maybe you can share also what is the 4th and the 5th model.
Yeah, so we're also running a vision language model on our robot. This is quite an interesting model because this allows actually to just let normal people write what they want to inspect in just English or Dutch or German text. It's simple as that. And that's very cool because you see what ChatGPT can do. You can give it an image and you can answer get all kinds of questions answered. But we want to make a vision language model that understands all the domain term knowledge of manufacturing.
Okay.
ChatGPT was never trained on that, right?
Yeah, exactly. But how do you train that?
Yeah, so we bought a very powerful GPU here at VBTI, and we are actually obtaining comments from inspectors and images also as well. And we use them to train our model to understand better the domain of quality inspection in manufacturing.
Mm-hmm. Do you use a standard VLM out of the box, or what is behind this VLM?
Yeah, we're using some, for this one, we're using some out-of-the-box VLMs at this moment. So it's also a little bit of a research topic. I think at the moment we're using Moondream. I'm not quite sure.
And how good does this model perform to train when it comes to domain-specific topics?
Yeah, that's an interesting question. So this is right now for us a little bit of a research. So in the base version, we can already get quite some things done. But right now we have some small data sets that we made ourselves. But we hope that if the robot gets a wider adoption in the market, we can build some very cool tools around this by basically collecting data and making the models better.
Mm-hmm. So is your plan to build a, let's call it, an inspection foundation model, or what is the idea?
That would be amazing. Yes.
Mm-hmm. So that you collect so much data that you can build at the end the inspection foundation model on high-tech industry stuff, right?
Yes, and it really understands all the specific names that people use here. And you won't find that in ChatGPT because that's trained on public websites and not on this internal knowledge of all these companies.
Sure, exactly. But how open are your customers to share this comments and names and topics and with you to build or to collect data for your inspection robot, and at the end building a foundation model for inspection topics?
Yeah, so until now the consensus has been a bit that most companies are okay with it as long as their data is handled very securely, right? So we don't want this data to end on any server, not on any cloud provider. We keep it very securely and we only train with it and no one else ever gets to see this data. So you make some very clear contracts about how you use the data.
Mm-hmm. And you mentioned the VLM and now the fifth model. What is the fifth model?
Let me think. We almost had everything.
So it's only 4.
Yeah, we are working also on a model to detect stains. And that is also just a simple supervised model in some ways. But yeah, the optics are quite different here because you want to use a bright light or maybe some UV light.
But when it comes to hardware, let's talk a little bit about the cameras. Do you need special settings when it comes to the camera?
Yeah, so right now we're using actually a very simple RGB camera, 5 megapixels.
Oh, wow.
Yeah, and actually most of the magic is in the software. And we can already find very small scratches with this, like 100 mu or something, like 100 microns. That is okay. But we are doing research on how we can improve our detection. So we are looking at maybe using monochrome cameras or other types of cameras, but especially the lighting is important here.
Yeah, exactly, yeah.
What we see, because what we see with scratches, for example, a scratch, you can see it usually from a certain angle, but if you rotate a part, maybe you cannot see it then. So you really have to have a couple of lighting directions to really find all the scratches. And that is something we really want to upgrade in the next iteration of this product.
Coming back to train the model or to train one of the 5 models, how difficult is it for you to get enough data to train the model? Because in the industrial sector, we do not have so much scratches on the parts, right? So do you work with synthetic data or generated data? What was your approach there?
Yeah, we did encounter this problem. So first,
it's not so easy as cucumbers.
No, you cannot just go around and grab a couple of assemblies and put them full of scratches. That's going to be very, very costly. We are using a combination of synthetic and real data. And synthetic has been proven pretty useful, but always you have to be a little bit careful because sometimes it seems realistic to a human, but AI models, they can really sometimes look at very weird patterns in the data that you don't really see as a person. So sometimes it works very well and sometimes it doesn't. But this combination of real and synthetic has proven very useful.
Mm-hmm. How do you generate these kind of data?
Yeah, so we have our own pipelines there. We're using mostly open source tooling connected together. One of the core components is Blender. So in Blender, you can apply all kinds of scripts to basically automate how you render certain parts. Yeah, we're using this to make all the accurate real-world lighting.
Mm-hmm. So you mentioned it's a cobot application, right? So you do not need a fence or something, right?
Yeah, so right now we're shipping it without a fence. But in the next version, we may include a box. And the reason for the box is twofold. One, you cannot accidentally hit a person. I mean, a cobot is pretty safe, but still it's not nice to get tapped on your shoulders from time to time. But also we want to block out some of the external light. So we see sometimes that people have factories that are pretty dark and some factories are very light. And sometimes it's next to the window.
Okay, that's interesting. But you are robotic agnostic. You can work with every robot on the market, or am I wrong?
Yeah, pretty much. We actually had a really interesting conversation today with someone about maybe we should use a humanoid robot instead of this robotic arm, so we can inspect very big objects.
Oh, that's a long way to go.
Yeah, that's a long way to go. But in the end, if we can control the humanoid and just take a picture at a certain point, there is nothing holding us back from doing this with the same software stack.
Yeah. But what is so special? From my point of view, it's a software stack. And how do you combine these 5 AI models? This is your USP at the end, right?
Yeah.
So is it an option for you, as you mentioned, humanoid robotics, to only to sell the software stack in the end? Because this scales like hell when it works, if it works. Because if you sell a robot or a robot in a box and you have to integrate the whole safety stuff, etc., 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 you have to integrate the solution into the shop, on the shop floor, etc., next to the machine, blah blah. So is it an option to say, okay, let's scale with only with the software stack?
Yeah, that could be an interesting idea. So the reason why I think we don't really do that is because we are solving customers' problem, and for that the robot is essential part, right? So we wouldn't be selling to the manufacturing companies we are selling the robot to right now if we would only offer software. So the full solution is where the value is for those.
But it could be an option to sell the software stack to the robotics companies or to the camera guys or something like that.
Yeah, that could be an interesting approach. Also, maybe to spread further than Europe, or I don't know. Yeah,
exactly. Because in the moment you are more, let's call it an integrator, right?
Yeah.
So you do projects with your customers and you have a great idea, but the next step is the idea how to scale this software stack at the end, right?
Yeah, that's going to be interesting. So one of the nice parts about it is that most of the hardware we can just simply buy, because as I told, we're right now using a simple camera, off-the-shelf cobalt, and a frame that is manufactured for us. So potentially we can already ship quite some systems right now, even though we don't have a very big manufacturing department.
Absolutely. Coming back to the beginning of our discussion, talking about the cucumbers, are you still focusing on, let's call, robots for farming greenhouses, or is it now really fully industrial AI applications, or are you still in the greenhouse field?
Yeah, we're actually in both fields. And sometimes I say jokingly that here in the region, in the Eindhoven region, you have farmers and high tech, and that's what we do as VBTI. But yeah, we do apply a little bit more focus now. So we do always choose projects in the agri sector, but also in the inspection sector and manufacturing. Those are the preferred types of projects that we can reuse a lot of our existing technology in.
Thanks a lot. Wouter, it was a pleasure to talk to you and to get an insight how you transfer your knowledge from the cucumbers case now to an industrial AI application. It was a pleasure. We keep fingers crossed for you and Adam 1. We will see Adam 2, or is it Adam 3, 4, 5? Do you have some plans to do that, to go in different domains also?
Yeah, we have plenty of plans, but you have to stay tuned and subscribe.
You can share one idea. What is Adam 2 doing?
Yeah, we are considering setups with more robots or more automated systems where you have conveyor belts, drones, or humanoids. Those kind of directions. Mostly a different form factor, because we see the table with the cobalt can address quite some parts. But sometimes you need to go bigger or more mobile, and then we can just reuse the same technology on a different form factor.
Exactly. I'm really looking forward to hear more from you. It was a pleasure, Wouter. Thanks a lot, and greetings to the Netherlands.
Thanks a lot, Robert. Thank you.